To understand atomic mass, also called relative atomic mass, we first have to understand the structure of an atom. This is a very simplified picture of the structure of an atom. In the center, we have the nucleus. All the particles in the nucleus are called nucleons. And there are two types of nucleons: positively charged protons and neutral neutrons. All nucleons have a mass of 1 atomic mass unit per nucleon. So one proton has a mass of 1 atomic mass unit, and one neutron has a mass of 1 atomic mass unit. Any nucleon has a mass of 1 atomic mass unit for each one of them. Going around the nucleus, we have electrons, which are negatively charged. And electrons are so tiny and have so little mass that in comparison to nucleons, we can ignore the mass of the electrons. We say that their mass is negligible. So all the mass in the atom, in effect, comes from the nucleons which are inside the nucleus. What I've just said can be summarized in this mind map. Pause the movie while you fill in these gaps. Choose from these terms here at the top. This is what you should have got. So an atom is made of nucleons surrounded by electrons. The nucleons are inside the nucleus. And there are two kinds of nucleons: neutrons, which are neutral, protons, which are positive. Add the number of protons and neutrons, and then you get the number of nucleons, and the number of nucleons gives the atomic mass. And the atomic mass is also called atomic weight or mass number. And the reason for this is because all the mass of the atom comes from the nucleons. Because the electrons have negligible mass in comparison to the nucleons. So that's why we round off to say all the mass comes from the nucleons. In a neutral atom, there are the same number of protons as electrons. That's why it is neutral. And that number determines which element the substance is. And that number is called the atomic number. And the atomic number is unique for each element. So for example, every hydrogen atom has an atomic number of 1, meaning it has 1 proton in its nucleus. And if it's an atom, not an ion, it also has 1 electron. Every helium atom has an atomic number of 2, meaning it has 2 protons and it has 2 electrons. It doesn't tell us how many neutrons it has. For that, we'd need to know the atomic mass. We use this notation when we write the information about an element. We write the element symbol, so for example, helium, and then on the left top, we write the number of nucleons, 4, which is also the atomic mass, meaning that one helium atom has a mass of 4 atomic mass units. Below that larger number, we have a smaller number. In helium's case, it's 2, and that is the number of protons in any helium atom, and that's the atomic number. So let's get some practice using this notation and understanding it. Pause the movie while you complete this table yourself. Hydrogen. So the bottom number here, 1, tells us that the atomic number is 1. There's 1 proton in each hydrogen atom in the universe, as shown here in the picture. If we have a neutral hydrogen atom, there must also be 1 electron to make the whole neutral. The mass number of this particular atom, this particular isotope of hydrogen, is 1, as shown by this number at the top there, 1. And that means that there is 1 nucleon in this particular atom, and that 1 nucleon is a proton we've already seen, meaning there's no space for any neutrons in this particular hydrogen atom. Notice that we can calculate the number of neutrons by taking the mass number, which is also the number of nucleons, and subtracting the atomic number, which is the number of protons, because the number of nucleons less the number of protons must be the number of neutrons. So for example, here The mass number is 1. The atomic number is also 1. 1 minus 1 is equal to 0. There are no neutrons in this particular hydrogen atom. Some hydrogen atoms do have neutrons, but this one doesn't. Helium. The atomic number of all helium atoms is 2, meaning that every helium atom has 2 protons in its nucleus. Every neutral helium atom, which is every helium atom because helium is always neutral because it is inert, it's a noble gas. So every helium atom has 2 electrons moving around the nucleus. So 2 protons, 2 electrons per atom. The mass number of this particular helium atom is 4, meaning that there are 4 nucleons in this atom. 2 of them are protons, so the other 2 have to be neutrons. Lithium. The atomic number of lithium is 3. There are 3 protons in every lithium atom. Every neutral lithium atom has 3 electrons. When lithium becomes an ion, it loses one of those electrons, then it will only have 2 electrons. So not every lithium thing has 3 electrons. Atoms 3, but ions would actually only have 2. But every single lithium thing, ion or atom, must have 3 protons per atom. That's what makes it lithium. The mass number of this particular isotope of lithium is 7, meaning that there are 7 nucleons, 7 particles in the nucleus. We've seen already 3 of them are protons. So how many must be neutrons? Of course, it must be 4 to make 7 altogether. 7 minus 3 is equal to 4, and that gives us the number of neutrons. 7 being the mass number, 3 being the atomic number. Mass number minus atomic number equals number of neutrons. This atom has 5 protons per atom, so its atomic number has to be 5, and it has to have 5 electrons per atom to be neutral. We look on the periodic table and we see which element has an atomic number of 5, and the answer is boron. Atomic number of every boron atom is 5. This particular isotope of boron has 6 neutrons. So you could count 6 green things there in the nucleus. 6 neutrons. So there are 6 neutrons and 5 protons in this nucleus, making 11 nucleons and therefore a mass number of 11. So we write 11 up there.